So, hello everybody. Welcome to our fourth Kia DHCP webinar. Today, it's all about databases and high availability. So, first we look at the database support, and later we take a look at the high availability options. So why do we want to have a database backend for a DHCP server? Now, we can store many different things from the Kia configuration in a database. That can be the lease information. It can be the host addresses and prefixes for reservations. We can have options and the host names and classification data. And also it's possible to store the whole configurations of subnets and pools and all that in a database. So if we store things in the database, especially when we store configuration in the database, we have a faster turnaround of configuration changes. As we will see later on, if we use a configuration database, then we make one change in the database, and that is automatically deployed to all our Kia DHCP servers. So especially if we have a large deployments with many servers, that can help. It also helps to access DHCP information like the lease information from scripts, because what you then need to do is to an SQL query if you use an SQL database, and there are SQL interfaces for almost all scripting languages. And you can even go as far as to build your own custom management interface for the DHCP service. Databases can be used to implement high availability. We have a look on that later in this webinar. And if you use an existing database system that already exists in your network, then there's probably already a backup system for that one. So you don't need to create an extra backup for the DHCP data, because it will be then in the database and the database will be in the backup system. But there's also some drawbacks of using a database backend. If you use the database to store leases, Kia DHCP must wait for the database, for the storage backend, to acknowledge that the lease information has been stored. The DHCP RC demands that. And depending on the database setup and on the implementation of the database, this is very often slower than using the in-memory, that is the lease file storage that Kia also provides. And some databases have some limitations, like you can't have leases that reach beyond the year 2038, which is not a big problem today, but might become a problem down the road. But also the database products, they work on this, and hopefully they will have that fixed in a few years from now. So what's supported? First, PostgreSQL, which is an open source object relational database system. It's quite flexible and extensible, and it's fast, and it has a permissive open source license. And you can find that on postgresql.org. That is my personal favorite. But I also often use the second option, the MySQL or MariaDB database, which is, I would say, the most popular open source SQL database. I say here network-based, because SQLite is maybe even more popular, but that's not network-based. MariaDB is a completely 100% compatible fork of MySQL, so you can either decide to use MariaDB or MySQL, both works, and both are bundled in most Linuxes and Unix systems. They are GNU public license version 2 licensed, and the links you find here on the slides. A little bit from the other side is the Cassandra database, which is not an SQL database, but it's kind of a cluster-ready database. So it's the default deployment of Cassandra is really to have not only one Cassandra database system, but a cluster of multiples, and they work as a logical single database, and it's very fault tolerant. Currently, support in Kia for Cassandra database is experimental. And Cassandra is available on under the Apache license, which is also one of the permissive open source licenses. So if we have chosen a database, we need to create the database configuration so that we can use Kia with that database. Usually that means we have to create the database, we have to create a user for Kia in the database system, and we have to adjust the access permissions so that the Kia process can access the Kia database. So in the next slides, I will show how to do that on PostgreSQL. Most PostgreSQL installations come with a dedicated user account for the database. And in most cases, that is the user called Postgres. And all database configuration steps should be done as this database user. So this first step is done with the tools provided by the SQL database itself. With Postgres, that's the PSQL command. We log into the database and then we create the user Kia with some secret password attached to that. We then create the lease database or any other database that we want to use to store the information there. And then we grant all privileges to that database to the user Kia. And then we can leave the Postgres command. For MariaDB or MySQL, it's very similar. We log into the database, we create a database, and then we create a user that is identified by some secure password, and we grant the privileges, we grant the access rights to that database to the Kia user, and then we leave. So it's mostly the same for PostgreSQL and MySQL, it's just a little bit different commands there. If you use MySQL or MariaDB, for that matter, there is an easy tuning parameter that you can set that really is a huge performance win for Kia, and that is to set the value for InnoDB flush log at transaction commit from the default value 1 to the new value number 2. And you can either do that for one session, which will be then gone when you restart the database, or you can put that permanently into the my.conf file. However, you should, before you do that change, read the MySQL documentation on that, because it can create problems during data recovery after a database crash. Once we have the database created, we can now tell Kia to make use of that database. And the first step is to create the database schema inside the database so that Kia will be able to store its information there. And we do that with the Kia admin tool. The Kia admin tool is a shell command that comes with the Kia DHCP system. And the first command that we use is the db-init command that is being used to initialize the database. It is also possible to initialize the database with the SQL script that you find provided with Kia, but if possible, we recommend to use the Kia admin tool because it does some extra checks before it applies the schemas. So here in this example, it shows how to initialize a PostgreSQL database as a lease database. And for MySQL, it's almost identical. You specify the database product you are using, the user, the password to the database, and then the name of the database, and the Kia admin tool does all the magic and creates all the schema files. Whenever you upgrade to a new version of Kia, that might require a new database schema. That is not always the case, but sometimes, if there are changes to the schema. It might also be that there is only an update for some database. So there might be that with a new version of Kia, that there is an update for MySQL, but not for PostgreSQL, or the other way around. Before you do an upgrade, please do a backup, because after upgrade, you might not be able to downgrade to an earlier version if you find a regression with a new version. We use the Kia admin db upgrade command to upgrade an existing database. But before we use that, we check whether we really need to do an update or an upgrade of the database. And we can use Kia admin to query the database version of the current running database. It's the same command both for MySQL and for PostgreSQL and for Cassandra. You just have to replace the db-product name here for MySQL or Postgres PGSQL. And then once you get the version number of the current database schema, you check that with the changelog or the release information of your new Kia version and see if that database needs to be upgraded. And if it needs to be upgraded, then you can use the Kia admin tool with the db upgrade command to apply the upgrade. So if we have the database now in place, we have to tell Kia to use that database. And we do that in the Kia configuration file. Kia can store different kinds of data in the database, and we can specify different databases or different credentials, or we can have even different database types for the different storage data that Kia can save to the database. So this is for the lease database. We also have the reservation database and we have the config database. You can store everything in one database, or you can decide to have it in different databases. This works for the DHCP v4 service or the DHCP v6 service. So in the configuration, we define the product type of database we use, the database name, the user that is used to access the database, our highly secure password, and the host where the database is located. There are also some other parameters that you can configure, not shown here, like the port number. And once that configuration is in place, you can use the -t command line parameter to the Kia DHCP v4 and Kia DHCP v6 daemons to test the configuration. And that configuration or that command with -t will test the configuration and will check if that is valid and if the support for that database is being compiled into the Kia binaries. So first we take a look at storing the host or reservations in the SQL database. So especially in larger deployments, DHCP administrators might want to manage the reservations dynamically or programmatically via an API. And the host commands that we have seen in the last webinar series can be used with the API to make changes to the reservations. And that host commands hook requires a database for storing the host reservations. So you have to create the host database in order to be able to use the host commands. Still, you can have reservations also configured in the configuration file of Kia. And if there are reservations specified in both the configuration file and in the database, the configuration file has priority over the ones in the database. So that can be used to override data in the database. Not that we would really recommend that, because it can be confusing to have the same reservations, maybe even with different data, ones in the database and the others in the configuration file, but just so that you know that that would be possible. So same as we've done for the lease database, we first create a database. You could also create a database which then hosts or which stores both the host and the lease database. I usually create two databases, one for the hosts reservations, one for the leases, so that I'm later more flexible and maybe can just scale that out to different machines if need be. And then again, the command db init from the Kia admin tool to initialize the database. And there's no difference in the initialization whether we use a lease database or a host reservation database. It's always the same. And once we have the database initialized, we then configure the database. And here, this is an example for a PostgreSQL database for the database Kia_host_db for the user Kia with a secure password and running on this very same machine. And if you want to do that for MySQL or MariaDB, you just change the type to be MySQL instead of PostgreSQL. So it's not really not very complicated. There's a special mode in which you can run the host reservation database, that is the read-only mode. And that might be because the reservations being stored in a database that contains other maybe sensible inventory information about the network, maybe usernames, maybe even passwords or similar data, or telephone numbers, something that you don't want to expose to the Kia process, that the Kia process might be able to write into that database. So you can do that. You can give the Kia user only read-only access to the database. And if you do so, you have to specify that in the configuration, because else during startup, Kia will test whether it can write into the database. And if it cannot, it will refuse to start. But if you mark that database as being a read-only database, then Kia is just fine and knows that this is a read-only database and will not try to write into that database. So now we have a look at the largest part of configuration that we can store in a database. That is the configuration for subnets and pools, the configuration database backend. That is currently only supported in MySQL database. And with the configuration backend, we can store subnet information, shared network configurations. We can store the global DHIPv4 and DHIPv6 parameters. We can have global option definitions and the options on networks and pools, and also global options stored in that database. The benefit of having the database configuration backend is that the local Kia configuration on each server can be simple and static. We can deploy each DHCP server from an almost identical pre-configured configuration. There's just one piece of information, which is the server tag that we need to change in the configuration. So you can build a template like for a virtual machine or for a container with Kia, and you can deploy the same container, the same virtual machine in many locations. And you have just to change one line in the configuration to have it run with an individual configuration, because it then fetches the rest of the configuration from the database. It also enables offline configuration, because you can pre-fill the database with the configuration for a Kia DHCP server that just doesn't exist at this moment of time. But when it starts to be created later on, it then can automatically already fetch the configuration from the database. It also helps with sharing configuration between high availability clusters, because you can just tag all the cluster members with the same server tag, so they will automatically fetch the same configuration. And of course, it helps with the automatic configuration management. So it is recommended that if you use the configuration backend, that you change the configuration via the configuration backend command hooks. While it is also possible to directly access the configuration on the SQL database level, the configuration command hooks, they do extra sanity checking, and they work over the REST API. So when we have configured a Kia DHCP server to run with the configuration database backend, it will periodically poll for the configuration from the database. And that is being configured with the config fetch wait time parameter. That takes a number in seconds, and that is the interval that a Kia DHCP server will look at the database and check whether the database has new config information. And if it has new config information, it will fetch that information. So here we have a graphical view on the configuration database backend. So in the middle, we have an SQL database cluster, a MySQL database cluster that contains the database for all the configuration. And on the top, we have different offices with Kia DHCP deployed, Kia DHCP 4, Kia DHCP v6. And in the headquarter, we have one Kia instance, which is not running as a DHCP server. It's just the configuration instance. So it has the Kia REST API, the control or command agent running. And its purpose is to translate between the commands that is being sent in via the API, either from the DHCP administrator or from an automated DHCP management system, to translate that into the SQL configuration that is then being stored in the database. And once that is in the database, the different Kia DHCP instances that are deployed in the offices, they will pull the database and they will check for new configuration in there. And once they detect new configuration, they pull that information upwards, reconfigure themselves, and then continue running with the new configuration. So when you need to change a couple of servers, what you would do is, as an administrator, you use the Kia config instance to inject new configuration into the database, and then all your servers will pick up that new configuration immediately, or almost immediately, depending on the interval time that you have configured. So here we see our configuration for the Kia instances that is part of the Kia configuration file. And the only line that you have to change between the different server instances is the server tag, because the server tag selects the different configurations. If you want to have all your Kia servers to have the same, exactly the same configuration, which is also possible, then you would use the same server tag everywhere. But if you want your servers to have different configurations, you would then have different server tags, and then you would use the server tags to tag the different configuration bits. Then, as with the other database configurations, we define the database type, the name of the database, the user, the password, and the host where we have stored that. The config fetch wait time that we see here will configure the interval that the Kia server will poll for new configuration. And by default, that is 30 seconds. So it's quite fast and often polling the database. In this example here, it's 120 seconds. So in order to work with the config backend in the database, two hooks are available. One is required and the other one is optional. The required one is the libdhcp MySQL CB. CB stands for configuration backend hook. And that implements the ability to load configuration data from the database. And that must always be present when the configuration database is being used. And that's part of the open source Kia distribution. And the second one, which is optional, is the DHCP control backend commands, which create the REST API commands that you can use to change the data in the database. That hook is currently only available for ISC customers with a support contract. If you don't want to use this hook because it's optional, then the other option is to use to directly change the configuration bits and bytes directly in the SQL database with SQL commands, which is also possible. So the objects that we can store in the configuration database are the global parameters, the option definitions, options, shared subnets, and pools. And all these object types have a server tag attached to them, one or more. And then each DHCP server has exactly one tag, while multiple servers can share the same tag. So we can have like 10 servers that have the same server tag and will fetch the same configuration, and others that have a different server tag and therefore will fetch different server information configuration. If we have a server without an explicit server tag configuration, it uses the special reserved all tag, which then will fetch all the configuration available. And also the configuration objects that are stored in the database have same kind of tags assigned. And we can have multiple server tags on an object. We can have objects with no server tag, which is then the empty tag, which is then currently not connected to any server. Or we can have objects that have the special tag all, which will then reference all the DHCP servers. And here we have a graphical representation of that idea. On the left-hand side, we have different Kia instances and different offices. And then on the right-hand side, we have a graphical view of the configuration database. And the configuration database has these different kind of objects that are stored. We have option definitions, we have pools, we have one specific option, domain name, and another option, Symbutio server, and we have a shared subnet configuration. And all these different objects have the tags attached to them, and I've color-coded the tags here to match the actual servers that have that server tag. So if the Office 1 servers, if they start up, they will fetch the option definitions, and they will fetch the option for the domain name. When the server from Office 2 is starting up or is running, it will fetch the option definition, it will fetch the pool configuration, the domain name option, the Symbutio server option, but not the shared subnet, because that's not in the Office 2 tag. And if Office 3 is starting up, it will get the option definition, the shared subnet, and the special Symbutio server option. So that was about the configuration backend. Very powerful and very, very useful. And here we have collected some additional information about the configuration backend. And if you are interested in that topic, I really highly recommend the video from Alan Clegg from the ISC webinar series that you can find on YouTube. So what happens if the database fails or the network towards the database fails? That can happen. Databases can fail, networks can fail. And if that happens during server startup and Kia detects that it cannot connect to the configured database, that is a fatal error, and the server will exit and will spit out an error. So it will not start when the database is not available. When it was already successfully started and already had a connection to the database, and then that connection goes down while it is running, then it tries to reconnect to that database. If it cannot connect to the database, the Kia DHCP server will log a fatal error, but it will remain running. It will not be able to give out leases to clients because it doesn't know if the configuration has changed, but it will listen for commands, and you can then use the API to restart it or to like change the configuration to have the database configuration point to a different machine, because the dynamic reconfiguration last time changed maybe the IP address of the database configuration, and that was a typo, and that was pointing to a wrong IP address. So you can remotely recover from this error. That was when the database connectivity was broken after reconfiguration. If the database connectivity is broken just during normal operations, like if the connection to the lease database or to the host reservation databases are gone, then the server will disconnect from all the databases, and then it will attempt to reconnect. While it is in that recovery process, it will not be able to serve any clients because it will not be able to store the leases if the leases are in the lease database, but it will continue to respond to API commands. Once the connectivity to all the configured databases is restored, then the server will just return to normal operations. If the connectivity cannot be restored after the configuration variable max reconnect tries, then the server will issue a fatal error and will exit. And also with the parameter reconnect wait time, you can configure the number of milliseconds the server will wait between reconnection attempts or once the connectivity is lost. The default value here for both MySQL and PostgreSQL is 0, which disables the automatic recovery and will cause the server to exit immediately if the database is lost. If you want to have Kia to attempt an automatic reconnect, then you should change this parameter from the default 0 to some sensible value that works in your network. So that was about the database. And now we switch to a different topic, which also relies partly on database, which is high availability. DHCP often is a critical resource in a network because if the DHCP service is down, machines, especially new machines and computers, cannot join the network. So for DHCP administrators, it's important that the service is up and running all the time. We want to make it redundant and high available. Kia supports now different high availability options. Some only require configuration changes and no changes to the software at all. And some others require the high availability hook, which is part of the open source free Kia product. Kia does not support the standardized DHCP v6 failover protocol, which is standardized in RFC 8156, because that doesn't really quite fit the way how Kia works internally, but it supports an implementation that aligns well with the Kia internal working, and it covers most use cases. However, you can't mix and match different DHCP servers. So you can't have one cluster with Kia and then another cluster node with another product that implements this RFC. That would work because they don't speak the same high availability language. So now we go over the different options you have to create a high available DHCP service. And for IPv6 networks with DHCP-v6, you can just work with configuration tricks. These tricks are either using a split pool or a shared pool. And in this tricks, we just exploit the vast address space that we have in IPv6. We have billions of IP addresses in an IPv6 network. So we can just use split pools and shared pools, which is not a good solution for DHCPv4 because, yeah, the networks indeed in IPv4 are so small that if we cut them in half and waste half of the address space, that doesn't work well. But in IPv6, we have so much addresses in one network, we can make use of them. So a split pool is basically we use the pool, the dynamic addresses that we give out, we split that in half and have each part of the high availability cluster, so both servers have configured them to give out 1/2 of the pool. The pools are not overlapping, so it's not possible that two servers will give out the same lease address to a different client. And if one DHCPv6 server stops responding, then all the clients will receive new leases from the remaining DHCPv6 server after lease expiry. And this is a graphical representation of that solution. It's a very easy solution. So we have the clients requesting, we have DHCP relays that send the packages upwards to both servers, and then the servers have pool definitions which don't overlap but are from the same /64 network. And in this case, both servers are alive, and there's no extra processing compared to non-high availability mode. So this is also quite fast. And then we have the shared pool, which is very similar to the split pool, with the difference that this time both pools overlap. And that also works with IPv6 because IPv6 has duplicate address detection. But even though it is possible that two different machines might get the same IPv6 address in this case, that's statistically very, very, very rare because we have billions of addresses in one /64 subnet. And I think, like, depending on the number of clients, but if you have even a really large number of clients, it will take hundreds of years until you see one instance that there will be a duplicate address given out. And even if that happens, it's not a big deal because the IPv6 network stack of the client will detect that with duplicate address detection and will recover from that and will just request a new lease. And this is the shared pool setup where we have on both sides, we have just completely identical configurations, the same pools on both sides. Another option is if you don't need dynamic pool allocations and you can work, or you would like to work with a complete static DHCP setup, then you can configure everything as a reservation. So every client in your network gets a fixed reservation with a fixed IP address attached to that reservation. There are no pools, there's no dynamic lease assignment in that mode. And now 2 or even more DHCP servers can be equipped with the completely same configuration, same reservations. And if you have the reservation in a database, that makes it especially easy because you have all your DHCP servers point to the same database, so they will automatically have the same reservation information. And then it doesn't matter which server the client will reach because every server will just return the same IP address to the client all of the time. This solution requires some kind of out-of-band synchronization of the reservation database. And as I mentioned, this could be done on the database level. But if you don't use database level, then you could use the commands hook to use the API to distribute the information to all the Kia instances, or just synchronize the Kia configuration file. And here we have the picture of the pure static DHCP setup, where two DHCP servers have the complete same reservation information. Now we come into the territory of databases and high availability. With Kia, it's possible, even without using the high availability module, the hook, to have a shared database system where you have multiple Kia DHCP instances and you configure them to connect to the same database. And then you make the database itself high available. So both servers will read the lease information or the reservation information from the database. And because they use the shared lease database, they have the same lease information and will not give out the same lease to different machines. What can happen in this case is that both DHCP servers advertise the same lease information to different clients, and then both clients come back and request that IP address. And then whichever client comes later will lose the race and will get a DHCP not acknowledged back. So it will need to restart the DHCP process all over again and will then query for a new lease. However, that's quite seldom, and it should not be noticeable by the user at all. It just then takes a second or two longer to get an IP address. If you go with this shared database, be aware that if you have a lot of leases or renewals, so if you have a high number of DHCP requests coming to your servers, that can be quite stressing for the database. And because multiple DHCP servers start reading and writing the same database, the database locking can be the bottleneck. And this is the picture of having an IPv4, IPv6 shared lease database. So we have multiple DHCP servers and they all connect to the same database, and redundancy is then on the database level. So, and then there is the high availability hook. The high availability hook is the most feature-rich high availability solution that is available for Kia, because it offers different operation modes. We can have the load balancing mode, we can have a hot standby mode, and we can have the passive backup mode. And we will look into all of them now. With the load balancing mode, two Kia DHCP servers will be active, and they will respond to lease requests. And the high availability module will take care that the lease information is always in sync between these servers. That works with a database backend, but also it works with the in-memory lease file database. So you don't need to have an SQL or the Cassandra database for using that. One prerequisite for this is that you have to configure the pools on each Kia DHCP server to be a split pool. Now, this is also okay for IPv4, even though we split the pool, both sides of the pool are active and being used, so we don't waste any IPv4 address space here. When one of the DHCP servers goes down, is not available anymore, the other DHCP server can take over the service because it has the full information about the leases and just can deliver the service alone. That detection of whether the partner is down is being done through the high availability protocol that is being spoken between the Kia nodes. And once the partner is online again, the lease will be synced back to both peers, and both will be starting and running active again. And here we have that in graphical. So we have a synchronization going on between the two Kia pairs. The synchronization is also be done via the REST API between the two cluster nodes. Both have the same configuration and they exchange the lease information. In a hot standby mode, the Kia cluster will have one node that is active and is serving leases, and the other one is passive. It will get the lease updates, but it will not serve any clients while being in the passive mode. And if then the secondary server, the passive one, detects that there's a failure on the primary, then it starts taking over the service and starts responding to DHCP queries. And it can do so because it has a full copy of the lease database. And this is the picture of the hot standby mode. Here again, we have the synchronization protocol running between the two DHCP servers. The right one is the passive one that only receives the update but never gives out leases. And the left one, the green one, is the one that is the active one. And the last mode we have is the backup servers. Kia DHCP supports any number of backup servers. So you can have like 2 or 3, but you can have 20 backup servers if you like. And backup servers are additional servers that receive lease updates, but they are not an active part of the high availability setup. So they are a machine that also has the lease database that can be used when the main machines are completely gone. It can also be used as a kind of an audit system because they receive all the lease updates, and then you can maybe store that changes in the leases into kind of an audit trail on the data on the backup servers. And this is the configuration for a system, which is a hot standby system with one additional backup server. So if the both servers above that make up the hot standby pair, if both are dead, the backup will not automatically become active, but it could make active with the administrator going into the configuration and changing it from being a backup server to an active DHCP server node. And then we have the passive backup, where only one Kia server is active and is serving leases. And then the others, one or more, are just passive backup servers. The benefit of having this configuration is that while with the hot standby and the load balancing modes, the active node always needs to wait for the partner to acknowledge the lease that has been synchronized over the synchronization protocol. In this setup, that is not actually the case. The active server will immediately give out the answer to the client and will send out the lease update to the backup servers, but it will not wait for the backup servers to acknowledge that that lease information is actually being received. And that makes it much faster than the other high availability options. In case of a failure of the active server, however, then the backup server will not automatically take over the service. It needs to be manually promoted to be an active server, which could be done automatically with the API calls. For example, you could have a monitoring system that will monitor your Kia systems. And if it detects that the active machine is not responding anymore, it then can send via the REST API commands to a backup server and turn that into an active server. And this is the graphical representation of the passive backup, where the active server, the green one, sends lease updates to the backup machine. So here we have a quick example on a configuration of a failover cluster. The nice part is that the Kia high availability configurations are symmetric. So all the high availability peers, they share an almost identical configuration file. There's only one difference, which is this server name, which defines the internal name in the Kia sync protocol for this server. And here, this is an example. At the top, we load the hook for the least commands, and then we load the hook for the high availability module. And then we have a block of high availability, which is all the high availability configuration. And the line this server name, that specifies the unique server name. The mode tells us which kind of high availability mode we are running, load balancing, hot standby, or backup. And then we have some configuration options in there for the sync protocol going between the different peers. And then we have the peer configurations. We have the configuration for server 1, which is actually this server here. We have its IP address and API endpoint, its role, and whether it does automatic failover. Then we have the secondary one, and we have one backup server configured down here, which just receives data, but it's not an auto failover. And this is the hot standby configuration, which is almost exactly the same, with the difference that we have the mode hot standby instead of load balancing. So once we have the high availability system running, how do we maintain that? As many other parts of Kia, the high availability module can also be controlled with the REST API. So we can send commands in JSON format to the Kia control agent. We specify that we want to send that command to the high availability module, and then Kia control agent will take that, deploy that to the high availability module, and that will reconfigure itself. So with the HA sync command, we can trigger a server to sync the least database just now with the selected peer. So we can use that, for example, if we plan to shut down the primary machine, we can send that to the secondary machine to be sure that all the least databases is synced at this moment of time, and then we can shut down the primary one. With the HA heartbeat command, we can check the current state. The HA heartbeat command is used internally between the peers to figure out if both or if all peers are still alive. But we can also use that command as an administrator to just check which peer is available and whether it is in the partner down state or if it is just working as normal. And here we see the result from one server that responded with a partner down. The status get command, which is also available for other Kia modules, will give us the current high availability configuration of that one server node. So we can read out the whole configuration of the HA module with that. And then there are the HA maintenance start and HA maintenance cancel command, which we can use in order to start or bring a server in maintenance mode. And if it is in maintenance mode, it will not serve any clients and it will not receive the least updates. We can then, for example, do a software upgrade on the machine, restart the servers, and then do an HA maintenance cancel to bring it into the cluster again. Now we have seen a lot of options how we can do high availability for DHCP. Which should you implement, you might ask? And this can be a hard question for users that are new to Kia or DHCP administrators that are new to the field. And on the next slides, I've collected some recommendations and guidance how to select a high availability option for your Kia deployment. So load balancing versus hot standby. The benefit of doing load balancing is that both machines are active, and so both machines are responding to clients. And especially if you have a complex client classing rules, which are CPU intensive. And if CPU might be the bottleneck in your Kia deployment, having load balancing really helps, because then you have two machines that are active and work on the client's request. So you can have double the throughput with that. However, load balancing mode requires the 50-50 split of the pools, and that is additional configuration and additional complexity. The hot standby mode is simpler, especially in the configuration part, but also in troubleshooting, because there are no split pools, and if there's a problem, there's just one server where you look at the log files. While with load balancing, and you have a problem in DHCP, you might need to look at both log files, and then you might even have to correlate the different log files, which is more complex. HA module versus shared database. The benefit of using a shared database is that you can have redundancy for more than 2 active DHCP servers. Depending on the database and the performance on the database, you can have like 5 or even more DHCP servers using the same database backend. But in that case, there might be the seldom occasion that 2 clients might be offered the same IP address, and only one will succeed and the other will get a DHCP not acknowledged from the server and have to start the DHCP process again. Now, again, this is not a big problem, because usually the user will not notice anything there. It will just take a second or 2 longer for a client to receive a DHCP lease. But that might be a problem in some networks where really the speed of connecting to the network is important. In the contrast to the shared database, the high availability module also works with the Memfile lease database, and that is the fastest lease option or lease storage option that Kia provides. It's much faster in most cases than an SQL database. So if lease performance is what you're looking for, then using the Memfile with the HA module is the way to go. And then the HA module versus split or shared pools. Split or shared pools only work with IPv6, that is DHCPv6. And these are good options if you are in an IPv6 only network. Few people are already in IPv6 only networks. Most of us still have some IPv4 legacy stuff around. So the HA module is more universal because it works with DHCPv4 and DHCPv6, and it works also across all the lease storages. It works with Memfile, it works with the SQL databases, and it works with Cassandra. So that's the most universal. And that concludes my discussion on databases and high availability options for Kia. In the next webinar, we talk about monitoring, logging, and Stork, which is the graphical web front end to Kia. And the last one in December will cover migrating from IC-DHCP to Kia DHCP. Here are some additional resources for you to read about Kia performance optimization and MariaDB 10 and Kia, and some specialities that you have to look for, and about using the Kia configuration backend with the database. And now let's look if we have some questions.
We actually have quite a few members of the Kia development team as well here to help us with questions.
Very good.
So Chris is asking, we're going to post the slides. We will post the slides. We always post the slides on the isc.org website under /presentation. So they'll be up, shortly, certainly by Friday, usually sooner. We also post the recording from the webinar. So a couple questions. I'll first start with a few that were answered. Stefan asked, are there plans to support storing the configuration in the other database backends? He was looking for us to support PostgreSQL, and I told him that's something that we have thought about, but at the moment we're more focused on adding functionality than on broadening the platform support. But, we also like PostgreSQL, maybe someday, unless Tomek, you're welcome to chime in if you like.
Yes, support for Postgres for config backend. This is something that we definitely plan to do. It's a matter when we are going to do it. From technical perspective, we like Postgres a little bit more. It's more convenient to work with. But it's undecided when we are going to do it.
So another question, a similar answer. Do we have a graphical UI? It says to use the config Kia instance, but I think this person is asking if we're going to have a graphical user interface for configuring Kia. And I responded that we're planning to add that functionality to Stork eventually, but we're not there yet. We're first focusing on making sure that we have a complete monitoring solution with Stork. Stefan asked, is there a method to see which configuration Kia is using when it gets the config from a database? And Marcin answered him that the config get command will return whatever is the currently used configuration. We have a question from Alberto that is not answered yet. If the config backend is enabled and the database is unavailable for an extended period of time, does the server work with the latest pulled configuration even after restarting the service?
To my knowledge, Tomek might correct me there. My understanding is if you restart the service and it cannot connect to the database while it is restarting, it will then fail and not start.
Yep, that's true. So if you're aware that your database is down, what you could possibly try is to do config write or config get and then store the configuration. And once you restart, you could do config set. But it's more like a stopgap measure to, like emergency solution, temporary solution, but it's not operationally good practice. So yeah, but in general, Kia would not be able to retain the configuration.
Yeah, once you have the configuration in the database is really a critical resource and must be high available as well.
Here's another question. In DHCP v6 with a shared pool, it was stated that the risk of two servers assigning the same IP address is low due to having a large address pool. And so the comment is, isn't this risk higher due to the fact that the only algorithm that we're using currently is an iterative algorithm?
Okay, so the first thing is that we should probably explain how the config detection works. So Kia looks whether the addresses are viable, and if it is, it then tries to insert the list. However, it's quite possible that during the time when it looked that the lists are viable and actually tries to use that list, someone else took the list. And Kia understands that it basically lost a race and needs to pick a different list. So this is unfortunate, but Kia is able to understand what happened and will not assign the list and will try again. So the only practical aspect here is that it's slightly slower because Kia has to try again. And regarding the iterative algorithm being the only thing, I'll let Marcin to say a couple words about this.
Yeah, we are currently using the iterative algorithm, and it's been the case for many years. But now we started designing a new feature, which we, by which we're trying to improve the list lookup performance, the free list lookup performance. So the server, basically maintains a queue of lists that are free to the best knowledge of the server, and will basically offer them. So this is going to improve the performance of mostly in cases when you're getting to the end of your pool, your pool is nearly exhausted. But apart from that, we're also working, in the same design, we're working on providing a random allocation capability, so as you're getting truly random releases out of your pool being offered, and that should basically minimize the collisions that you may observe, that you may potentially observe now.
Okay, I think the bottom line is that the biggest issue that you're going to see is if your pool utilization is very high. So someone is asking if we can mail out the recording and the slides. I'm happy to do that. In the past, sometimes, especially with the webinars that we had a whole series, people complained that there were too many reminders and too many emails. But I'm happy to do that. That's no problem. And it looks like we don't have any more questions that are unanswered. So surprisingly, because usually this is a topic that people have a lot of questions about, but perhaps it's just that we've run pretty long with the main presentation. So I think that's it. And thank you again, Karsten. And we'll see everybody in 2 weeks.
Is it 3 weeks next time? Because we have
it's 3 weeks actually. Yes,
you're absolutely right. Right. It's we have a skip a week.
Yeah. So thank you, everybody. See you next time.